This video is a quick introduction to what exponents are, what they stand for, how we use them. If you're working and you see something that looks like this, 10 with a little 2 raised up, sometimes they call it a superscript if you were typing on the keyboard. That means 10 squared, that's how I would say it, or 10 to the second power. I could say it either way. So what does squared mean? Well, if I see something that says 10 squared, what that really means, it's sort of like doing an area kind of thing. That means if I took a square and I made it 10 on this side and 10 on that side, it would be 10 squared, and I would take the 10 times 10 to find my area, which equals 100. So 10 squared really just equals 100. 10 to the second power equals 100. What if I had a different number? What if it was 3 squared? That means I would be taking a square and making it 3 on each side. So to find the area, I'm going to take 3 times 3, which equals 9. On your calculator, they have a button like this. It may look like this, and just say x squared. So my square numbers are, I just take the number, and I multiply by itself, and it's going to give me an answer that would tell me what the next biggest square is. So if right now I'm at 3 squared, if I went to the next biggest square number, it would be 4 on each side. 4 times 4 is going to equal 16. So sometimes you may hear people talk about square numbers, and they go 1, 4, 9, 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. What does cubed mean then? Because I could have something that said 10 cubed, which would also be, say, 10 to the third power. Since this says cubed, and the last one said squared, you can kind of think, oh, we're going into 3D now. So I'm going to have a shape that's like this, that's 10 on this side, and 10 on this side, and 10 deep. So now I'm going to take 10 times 10 times 10, which is going to equal a 1 with 1, 2, 3 zeros after it. So 1,000. 10 cubed, 10 to the third power would equal 1,000. So if it says cubed or third power, you can just kind of think you're building a cube out of our little tiny cubes. If I was doing 4 cubed, that would mean I have a cube that's 4 on this side, 4 on that side, 4 on that side, and I would go 4 times 4 is 16, and then 16 times 4 gets me to 64. So up here I have some 10 to the fourth power. I don't know of a nice way to say that one, like they have 10 squared and 10 cubed. I just say 10 to the fourth power. 10 to the fourth power means I've got 10 is my base number, and I'm multiplying it times itself 4 times. So 10 times 10 times 10 times 10. The 4 is the exponent, and the 10 is the base number. So it's going to kind of tell me what's going on. If I want to find out how much that's worth at all, since this has so many zeros, I'm just going to go like this. 1, 2, 3, 4. Get rid of my 4 zeros. They're at the end of my number. And just multiply what's left. 1 times 1 is 1. Times 1 is 1. Times 1 is 1. Come over 1, 2, 3 spots, put my comma in, and it's 10,000. So 10 to the fourth power, or 10 to the fourth, is 10,000. 10 to the sixth means I'm going multiplying tens. How many of them do I need? According to my exponent, 6. So 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6 of them, which means I'm going to have a 1 with 1, 2, 3, 4, 5, 6 zeros at the end. So 10 to the sixth power is really a million. One of the reasons scientists and mathematicians use this notation is because 10 to the 6 is a lot shorter to write than 1 million. And if you were dealing with things in science like how many miles to Jupiter or Mars, or how fast the speed of sound or the speed of light are, it's a lot easier to use base numbers with exponents than writing out the entire number. What happens if I don't have 10 as my base number? No big deal. This means I'm just going to be multiplying 8s. How many of them are there going to be? 2. So 8 squared, or 8 to the second power, is just 8 times 8, which equals 64. On this one, 5 is my base number, so I'm going to take 5s, and I need 3 of them. 5 times 5 times 5. Start 5 times 5 is 25. 25 times 5, I'm going to think quarters. So really it's just 5 quarters, 25, 50, 75, $1, $1 and a quarter, but don't put a decimal point in because we're not really doing decimal, so it's 125. Here's a couple for you to try out. Stop the video. 2 to the 4th power means I'm multiplying 2's, and I need 4 of them. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 to the 3rd power, multiplying 3's, and I need 3 of them. 3 times 3 is 9, 9 times 3, 27. That wasn't too bad. Stop the video when you try it out again. 11 squared, 11 to the 2nd power. I'm multiplying 11's, and I need 2 of them. 11 times 11. If you don't have that memorized, I'm going to come up here and just multiply it out Marco Polo style. 1 times 1, 1 times 1. Marco Polo, put my 0 in there. 1 times 1, 1 times 1. Add them up. 121. So 11 squared, or 11 to the 2nd power, is 121. 7 to the 3rd, 7 times 7 times 7. So 7 times 7 is 49. 49 times 7, no, I don't have it memorized. 7 times 9 is 63. Carry my 6. 7 times 4, 28, plus 6 more, 34. So 7 cubed, 7 to the 3rd power, equals 343. What if I give you the numbers that are being multiplied together? Could you give me the exponent and the base and exponent and what it equals? Why not? If I notice I'm doing 10 times 10 times 10, so 10 is my base number. How many times did I do it? 1, 2, 3. So that's really 10 to the 3rd power. And if I multiply this out, 10 times 10 is 100, times 10 more, 1,000. 6 times 6 times 6, 6 is my base number. And I'm taking 3 of them, so it's 6 to the 3rd power, 6 cubed. And then I need to figure out what that really is. 6 times 6 is 36. Times 6 more, 36, carry my 3, 18, 21, 216. Stop the video. Here's a couple for you to try out. So my base number is a 10. How many of them do I have? 1, 2, 3, 4. So it's 10 to the 4th. When I want to work it out, I'm just going to go like this. 1, 2, 3, 4. And then what am I left with? 1 times 1 times 1 times 1. Some people also know already that if I have 10 to the 4th, that means it's just going to be a 1 with 4 zeros. 10 to the 7, I'm going to have a 1 with 7 zeros. 10 to the 24th, I would have a 1 with 24 zeros. Second number, base number is a 2. Got 1, 2, 3, 4, 5 of them. 2 to the 5th. Start working out. 2 times 2 is 4. 4 times 2 gets me to 8. 8 times 2 is 16. 16 times 2, 32. This is sort of a doubling kind of pattern. If you think about it, this 2 to the 5th, that means this would be like if I doubled something every day for 5 days, excuse me. 2, so I started with 2, I doubled it, then I doubled it, then I doubled it, then I doubled it. You can see the numbers are starting to get big really quick. Stop the video when you try it out. Base number is 1. I'm doing it 3 times. 1 to the 3rd power. 1 times 1 times 1 was 1. 20 times 20. 20 is my base number. I'm doing it 2 times, so 20 to the 2nd power. If I'm multiplying this one out, I'm going like this. Get rid of my 2 zeros at the end. What am I left with? 2 times 2 equals 4. So 400. One more for you to stop the video and try out. Base number is 4. I'm doing it 3 times. 4 times 4 is 16. 16 times 4 gets me a 64. Base number is 0. 1, 2, 3, 4. 0 to the 4th Well, 0 times anything is 0. Let's try a couple more out. This time I'm giving you the answer, and these are only going to be with base numbers of 10, because that's the one that's used the most, especially in scientific notation. So 100 really means I took 10 as my base number, and I got 2 zeros, so it was 10 squared. And how did I get there then? 10 times 10. The bottom one, my base number is 10. How many did I do? 1, 2, 3, 4, 5, 6. So that's 10 to the 6. 10 times 10 times 10. 3, 4, 5, 6. Got a couple for you to try out. Base number is going to be 10. I did it 1, 2, 3 times, so 10 cubed. 10 times 10 times 10. 100,000. Base number is 10. I went 1, 2, 3, 4, 5 times. 10 to the 5th power. 10 times 10 times 10 times 10 times 10. And one more page for you to try out. We've got 10 to the 1, 2, 3, 4th power. 10 times 10 times 10 times 10. That's not bad. And then down here we got 100 million. So 10 to the 1, 2, 3, 4, 5, 6, 7, 8th power, which means I'm going to have 10 times itself 8 times. There's 4, 5, 6, 7, and 8. So that was exponents. All I'm doing is taking the base number times itself, how many times the exponent tells me to.